Okay, so we're still in chapter 3, or I'm sorry, 13. And that is because we're still discussing ANOVAs, which is the analysis of variance. And today we're going to talk about what we call the complete randomized block design. Okay, so that's what we're doing today, the complete randomized block design. So what this is going to do for this is going to help us design a better ANOVA. So what this is going to do, this will improve our original ANOVA, our analysis of variance, okay? And we will be adding, like I've already said, we're going to add another factor to help reduce the unexplained variability in each group. So that's what this is going to do for us today. Adding the second factor, it's going to make our ANOVA better. And by doing this, we're going to reduce. We're hoping it will help reduce that unexplained variability in each group. I'm going to show you where you see that and where we're going to see that difference. So what this is called a block variable. Okay, so we actually, when I call it, I don't like say the whole name out. I'll just say like an ANOVA with a block variable. That's what I call it. So this is a variable believed to have an effect on the response. Remember, that's my Y variable. It's my numerical variable. But it is not what we are interested in. So we're going to add this variable as a block variable. We believe it's going to have an effect on our numerical variable, meaning it's going to help explain some of that unexplained variability, but we're not interested in it, okay? So we do not report. So this is in our testing right up. We do not report about this variable. So you will see, and I'll let you know where we mentioned this block variable, but we don't really include it much in the write-up. We need to include a little bit to say that we used it, but we don't really use it a lot. I want to let you know a common block variable is like an age group. We might not actually be interested in the age group, but the age group might have an effect on whatever our numerical variable is. And so then we add that to our design and to our ANOVA, and it actually helps describe it better. Okay. So I actually want to run through an example, and this is going to be the example we're going to do today, where we look at the ANOVA by itself, like we did last class, and then we add in this block variable to see that difference, to see that change. So we'll look at those two. So this example, I believe it's example 1. I think it's like the only example, but it's on page 5 of the typed notes. Okay. In this example, I'm going to pull it up and then we can look at it and we'll run through the mini tab together. But we're going to look at it just like we would last class. So let me get my notes pulled up here. Okay, so I'm going to scroll down to page 5. The notes are not very long because the lecture is not very long. Right here it is. Okay, so this example, yeah, it's not even numbered because it's like the only example. So this example, I can number it. Here we go. There we are. So for this example, we're considering looking at 7 different items from a grocery store. And not just from one grocery store, but we're actually going to visit 3 different grocery stores. And we want to know if there's a difference in price for these items between the grocery stores. Okay. So our numerical variable is price, right? And, or you could say cost, right? Either one would work. And my factor is store. So which store is how I'm breaking it up, right? And I'm going to look at like my bill for these 7 items for each store. And I want to see if there's a difference, right? So that's what we're going to do with this initial example. And we're not going to think about the block variable just yet. So if you look, these are the items. So over here on the left, it's like a nice chart, right? Remember, Minitab can't handle it this way, but it's visually nice for us. The items are Tide, butter, excuse me, eggs, orange juice, Diet Coke, bread, and peanut butter. So we're going to buy these 7 items from 3 different stores in the area. Minitab needs the data over here stacked. Okay. So right now we're going to ignore the item column. So I'm going to share my screen with the Minitab. Actually, I didn't do it yet, so I need to actually pull this up and download it. So what I'm going to do, I'm going to possibly, if I can get back in, I'm going to share, oh, sorry, I stopped sharing by accident. I'm going to share my Minitab screen here so we can take a look. All right, so you can see I already have it stacked. So I do that for you guys a lot, right? I might show you unstacked data because it's very pleasing to the eye and it's easy to read and see. And here I'm just have it stacked for you. So let's just go ahead and build the ANOVA the way we would. So stat, ANOVA, general linear model. I'm gonna go in here, my numerical variables price, my factor is store, we're ignoring item at the time, okay? Because we're just buying the same 7 items. So I'm gonna pull up this model. So right here, remember my ANOVA, right here, the analysis of variance, this is what I'm studying. So take a look at my F-test statistic, it's 0.54, and that leaves me with a p-value at 0.589. So for this problem, I am not going to reject my null because look at my p-value is pretty large, right? It's 0.589. So it's big enough that I'm not going to reject my null, meaning I'm not showing a difference between stores. So I'm saying that the store does not have an effect on my price of those 7 items altogether. Okay, so we can see that. Remember what the F-test statistics made up of? It's this 1.388 divided by that 2.548, okay? And so what we're looking at here is we want to see if we can bring down this 2.5. So this 2.5 number here, this is what we call our unexplained variability right here. I'm going to write this out in just a minute. Actually, maybe I'll just write it out right now here so then we can see. So we're going to look at F. I like to write it and not just say it. So if we think about what F is equal to, that's my MST divided by the MSE, right? So this is for my factor or my treatment. And the denominator is for the error. So it's the mean of the sum of the squares, right, for the error. And the numerator is the mean of the sum of the squares for the factor of the treatment. The numerator is what we call our explained variability. And then our denominator is what we call the unexplained. That's the error. Okay, that's the unexplained variability. And if you think about it mathematically, we have a fraction. If we want this number to be large, that means that we're going to reject the null, right? A larger f means we're further out to the right on the curve, meaning we'll have a smaller p-value. We'll reject the null, saying that we're showing a difference. In order to do that, we need to have MST large, right? And MSE small. So how can we make this MSE smaller? How can we make the unexplained variability smaller? That's what we're thinking about doing. So what we want to do is we want to reduce the unexplained variability and move some of it to being explained. And that's what our black variable is intending to do here, is we're trying to move some of this number into an explained variability by using that block. Okay. So here, if we look, we have explained variability plus unexplained variability, okay, equals my total variability. Now, you're going to notice the total variability does not change. It's not going to change. This number will remain the same. It's just we're going to move some of this. Okay. So this will just stay the same as explained variability. And then we're going to break this number into two. We're going to have explained, and I'm going to just put block. So let me put explained by the block here. And then the rest of it that is unexplained, meaning that there probably is really a difference. Okay. So, and then this will still be the total variability here. So this number does not change. It is the same, that total variability. This unexplained variability just gets broken out into two different numbers now, okay, by adding that block. That's what we're going to look at. So let's take a look at that mini tab again and change it up and see what happens to our output when we add that block. So we're going to look at stat ANOVA, general linear model again, and then I'm going to go back into fit the model because I'm going to change some things. And what I'm going to do is my response is still my numerical variable and my factor is still my store. It's just now I'm going to add a second factor in here. So I'm going to bring item because item's my block. So I'm going to bring that over second there. And that's all I'm going to do to make a difference here in my ANOVA. So I'm bringing in the second factor. I'm just not interested in that. So yeah, it's the same 7 items, but I'm not actually going to report on the item. I'm looking at my overall bills. So what does this do for us? So what this does is this makes it so we're comparing. So what it's doing is it's saying, okay, I'm going to compare tide to tide between the stores, butter to butter between the stores, right? And so it's making it so I'm actually going to compare those particular items to each other and not just my total bill at the end, the 7 items. That's what that's going to do. So I'm going to click OK. You're going to see like the output looks really similar, but it just has a little extra, right? So look at right here, factor, store, and then it has item, right? And it has all the different items there. So I just want to think about in the original ANOVA that I built, why do I think there's so much unexplained variability? Well, it was probably coming from something like eggs that's like $1 to something like Tide that could be like $20, right? Depending on the size that you're buying. So there's a huge price difference there. And that's where some of that unexplained variability is coming from, where if I'm tying those items to each other, kind of like what you do in a paired t-test, right? You're like lining them up and you're comparing them, very similar to that paired t-test like that. you are going to do the same thing here. That's what this just does for us. Just by adding that next block or that other factor in there, it does that for us. So now if we look at the analysis of variance, which again, this is all we're studying right now, we can see our F now is 22. That is huge. It has grown so much and my p-value is very small. So let's take a look under here, okay? So if we were looking before, my unexplained variability, if we look right here, my sum of my squares, it was still, I don't know if I can go back. I think I lost my other tab. I think I've done something where I've lost my tabs. I'll have to check that out. But right here, when we have this, we still had 45.859 right here. And we still do, right? It was just in my error alone. And so look at what I've done. I've moved 45.1 of my error variability up to the item. That's what putting that blocking variable did. It moved it into explaining that variability here. And now I only have 0.7 of unexplained variability. That's a lot. So then when it takes everything over here to make my F test statistic, when I divide my numbers, it's now has a small denominator, which leaves me with a large F and a small p. When we're reporting anything on an ANOVA with a block, we ignore this line right here. So when you are doing your test write-up, you're still going to report your F value for your true factor that you're interested in. Okay, so it's gonna be the 22, very small. Okay, my degrees of freedom are still 2, 12. Okay, so we just want to think about that, how that all comes in. Okay. All right. So it doesn't change the total variability. It doesn't change the total that was here. It just moves it. Just want you guys to get that. All right. So let's talk about how we're going to write up and everything like that. So let me just write a few things down here. So I did mention this. We're still going to study the F and P value of the factor. Now here, I'm just going to say for this example, that was the store. Okay, we're not going to report it for the other factor. So for the write-up, I'm not going to do the complete write-up, but I'm going to just kind of mention what has changed. So my ANOVA write-up, we've shortened it last week. We're still going to continue shortening this a little bit or keep it that shortened way, but I have to make a couple changes. So I want to just run through a few things. You know how we get to know the data? We still want to do that. And when we get to know the data, you know, it asks different questions like building box plots, all that stuff. I want you to know you do not include your block variable here. So when we're looking at the box plots, when you're ranking the means, all of that, you will do it just like last class. You will not include that block variable. Then when we're looking at our ANOVA test, we're going to build the ANOVA. With the block variable, but we do not report the block. The one place where you're going to see the difference for the block is if you write a goal, which you don't have to do that at this point for this test, but you'll also see it in the conclusion. So a conclusion would look something like you just want to add the wording after adjusting for the differences in, and then whatever your black variable is. So for this example we're studying right now, we would say after adjusting for the differences in item, and then I would continue, I would say at the 5% level of significance, and then I would just continue with my normal conclusion statement that my sample does or does not support that the factor has an effect on my variable, right? So that's what you would do. You could write this in the beginning, you could write it in the end, wherever you want to fit it in your conclusion statement. But if you are using a block, we want to mention it someplace. So just someplace, and you might have it in your goal if you're writing a goal, but you need to mention it in your conclusion that, okay, I am running this test, but I need to mention, all right, I do add a little something else to help explain that unexplained variability. That's same. Okay. Then when we get to our post hoc analysis, or two keys, right? So when we take a look at that post hoc or that two keys, the comparison is still on the one factor only. So it's not based on the item anymore, or my blocking variable. So what I mean is, think back, because I know it was a while, think back to when you run the two keys, you have to like check the box right next to your factor. So what's going to happen is when you get into two keys, it will show two factors now. It will show your regular factor and your block. You need to check the box for your one factor only, right? So we will not check, let me just write it like here, so we're clear. Do not check the box for the block variable. Just to be clear. So we will not be checking that box because we're not running two keys about that block, because that's not what we're interested in. We're running it on the factor. Okay. And then for my requirements, we're going to run them without the block. Okay. So we're going to look at NPP without the block, and same with Levine's. Remember, Levine's was the equal variance, so without the block. So the only thing we're really looking at, sorry, I didn't have that up. The only thing we're really looking at with the block is going to be my ANOVA test. Everything else is done without the block. Okay. So let me just write here. Do not click on the block variable here. All right, so let's just run through this example real quick, and then I'll let you guys get to your daily. So I'm just going to go over to Minitab so we can see what we mean. So if we're in Minitab, when you're looking at your box plots, you're still going to go to Graph, Box Plot. So with groups, right? So my variable is price, and my categorical, or how I'm splitting up the price, is by store, not item. So I'm not interested in item, I'm interested in the store. Right? Can add my mean symbol if I want. Okay, so here it is. Okay, so I can get an idea of what's going on between each store, right? Doesn't look like a huge difference. So same thing, if I'm looking at my basic statistics, I'm not going to include my blocking variable. I'm going to only include store. I'm not going to get fancy. I'm just going to click OK, right? So when I rank my means, look at my means here, 3.1, 2.8, 2.2. So I'm going to rank them in that way. So smallest to largest, C, B, then A, right? And then I use this with two keys if I reject my null. We only run two keys if we reject the null. Okay. So when I go back into my ANOVA, we know we did reject the null, so I can go ahead and look at the comparisons. I only reject the null though when I have that block. So when I go into my comparisons for my two keys, remember everything should be in here because I've already built my model. I just have to just skim through this and make sure everything looks good. It's the price is my numerical, that's right. I am doing a pairwise comparison. I am looking at two keys. Now look at here, I have two things to choose from. I'm only going to check the box for store because I'm not interested in the item. Remember for results, I need to ask for test and confidence intervals and then click OK. So this is really nothing new, right? We've done this, just going over it again since it's been a while. Remember, we can study the CI or the p-value. So look at this first CI. It's negative to positive. That means it includes 0. That means A and B are the same. So store A and store B are the same. And then look at here, both negative. So I'm showing a difference here. Okay, so I typically like to use the CIs, but you can use the p-value. The p-value might be a little bit quicker and you're just looking for that p-value greater than 0.05 to mean that they're the same. And here it is, that top one. So it gives you the same results no matter which one you look at, the p-value or the CI. So you don't have to worry that one's going to give you different results. They give you the same results. It's just whichever one you choose to look at. Okay. So remember when we rank the means, we underline what's the same. So A and B will be underlined and that's it. Everything else will not be underlined. Then remember you make a conclusion based on this. So let's see if we can take a look at our typed notes and see what we have. So you can see everything all written up. Look at here's my test. Remember my test, we kind of shortened it. So I'm gonna gray this out because we said we don't need to do the goal. We shortened it so we have our numerical variable and then our factor. And then look at this right here. So I highlighted anything in yellow that we include different from last test. Right here it says in yellow, item is the block variable. You don't have to make it in yellow. I'm just showing you that's the difference from last class to this class. So right there, I'm just adding in that we are including a block variable. My null still that they're all the same. My HA's one's different. I include my output. Here it is. I just put a strike through on that item because I want you to realize we're not reporting about that item and we're not even looking at that. We still just look at this top F value and P value, the one for the store. Here's my requirements. They're grayed out because we don't have to include these. Remember, that's kind of like a follow-up, something that we will include if asked. In my results, here's my F test statistic, my degrees of freedom, and I have my p-value. And then for my conclusion, right there, after adjusting for differences in items. So right there's that difference, the 5% level of significance, and then it does show that the store has an effect on price. So then I get to my two keys, which we just did. I just wanted to show you the underline just to refresh your memory. You underline that anything that's the same. I highlighted the ones that are the same. And then I'm going to make some sort of statement. Now, remember, you always want to take a look at the question and see what is it asking. But if it's not really asking anything, then you could talk about the highest and the lowest, right? So I could say that store A and B have the highest price. They're statistically the same or not different. And then C is associated with the lowest store prices on these 7 items. And that is statistically different from the other 2 stores. So something like that. Okay, but that's all typed up there. You can see these requirements in here, how that's all written up. You will be asked to do the requirements today.